want to be forever young. Do you really want to live forever?
One life,
forever,
one love,
and ever.
one soul.
All right, you want to get started?
Sure. I have John Myers, and I want to welcome you all here to Dr. Bill's Sierra Sciences. It's very nice of you, Bill, to have us in for this time today. There'll be plenty of time for questions. There'll be, if we have, are we able to do a lab tour?
Yes.
We can do a lab tour. That's fantastic. A lot goes on here. I've known Bill for 10 years, just through some coincidental things going on in the business world. Dr. Bill, as you probably know, that's why you're here, is one of the world's most foremost geneticists, gerontologist, and incredible purveyor of the sciences of anti-aging. And he's been very successful. We have some books. I'm going to get out of the way and put myself on mute. And Bill, thank you for having us.
Well, you know, John met me because his business opened up over there, and I went over because we needed phone. This is how it all started. I also forgot, I have cards here, business cards. Anybody wants one? Let me just pass the app down that side. Okay, so I don't know how many know who I am, but I'm the president and CEO of this company, Sierra Sciences. I'm also the founder. We actually have a few small companies, and we're a division of another company called Andrés Inc. But Sierra Sciences was founded in 1999, and my background has been that I'm defined as a medical researcher. When I first got my PhD and became a medical researcher, the term didn't really exist, but now people are getting PhDs in medical research. So I'm one of the original medical researchers ever. And I actually played quite a role in a lot of the early things that occurred in biotech. That includes the discovery of human growth hormone. I was very instrumental in that back in the late 70s, early 80s. Tissue plasminogen activator, which is a drug that if anybody who's had a heart attack, ambulance comes, first thing they do is they inject you with TPA, tissue plasminogen activator, to break up the clot. I'm one of the inventors of that. Erythropoietin. You may have noticed that human growth hormone is not just to make dwarfs bigger, it also is a legal sports enhancing drug. Okay? Well, so that wasn't my intent when I first was involved in inventing it, and it wasn't my intent when I first got involved in discovering EPO either. EPO is called erythropoietin, and that's the drug that Lance Armstrong used to cheat with. So I'm actually one of the inventors, or actually I'm the only person that can say I'm the inventor of the two top illegal sports enhancing drugs. It had nothing to do with the sports thing. Ms. Journal did a story on me about 10 years ago now, where they said to me, so since you've been involved in the top two illegal sports enhancing drugs, is this thing you're working on now, lengthening telomere, is going to be the next big illegal sports enhancing drug? And I said, well, it's definitely going to enhance sports. Okay? People thinking that what I'm going to develop is definitely going to be more athletic, more successful. And if they make that illegal, it's going to be a lot of young people, a bunch of old people compete in the Olympics, because everybody's going to be taking what we're trying to develop here. But do you want me louder?
A little bit, please.
Oh shoot, I
Just
don't
to
have a
hear.
loud voice. So do you have
Just
a
to-
microphone I could use?
I do, yeah. We can, yes.
Or like especially a lapel?
Just continue. Just continue. It's fine.
I never told these folks about your illegal activities, Bill.
Well, we can be here all day on that. But it didn't stop there. I'm also the inventor of thrombomodulin, which is the best. So what's so funny about thrombomodulin?
No, I'm just thinking, it didn't stop there, there's more drugs.
That's one of your illegal sports enhancing drugs. Thrombomodulin, actually, poets say, oh, you know, that has something like ionic pentameter. But not maybe you really recognize that. Thrombomodulin is actually the best drug ever for preventing blood clots. And unfortunately, we invented it back in the late 80s, maybe early 90s. And it's still in clinical studies because the FDA is very opposed to it because it competes with other products that are already on the market that don't work nearly as well. And so it's been a real struggle. It's like, I don't even, there's a different company called Burlex Biosciences that I used to work with, where we discovered this. I was the director of molecular biology for that. And it is a fascinating drug, and this is one of the reasons you'll hear me talk about FDA as being one of the biggest criminal organizations on the planet, because you're more interested in the companies, the big pharmaceutical companies selling products than they are in the health of people, and it just drives me nuts. And they blocked the clinical study several times because they said it doesn't exceed a. Okay, so thrombomodulin is still in clinical studies, but I can't wait for it to get released. Osteoinductive factor is something else that is involved in osteoporosis, stuff like that. So it's a kind of a cure for osteoporosis. That too is also still in clinical studies. Beta-seron, which is one of the more exciting, it's the very first drug ever for treating multiple sclerosis. Okay, well, I'm one of the inventors of that. Long, long time ago. And when we first invented it, there was such a high demand for it that we had to have a lottery. Okay, so that was in, I want to say, late 80s, early 90s. We had to have a lottery, and it was like only 10% of the people that needed it were able to get it. Now there's better things out there, but this was the very first thing ever for treating multiple sclerosis. Then, of course, my most exciting one is telomerase, which has turned out to be the most important enzyme, I think, on the planet. I think it's going to go down in history as being the biggest discovery of all time after we actually show what it can do. So besides that, I've been in biotech now for 38 years. I'm on 50 US issued patents. Just on telomerase, I've got more than 50 US issued patents. So I've been quite active in the field. My areas of focus have been mostly cancer, heart disease, inflammation, and aging. Aging more recent, but by being involved in aging means that I'm actually involved in all these things because they're all age-related diseases. In 1997, I was the second place, actually, for United States Inventor of the Year in the United States for the patents that we'd done. But that was actually for my cancer research. So, I mean, if anybody here ever wants any advice on cancer, I'm actually quite an expert on that. And I can also refer you to people that are more expert than me because they're all good friends of mine. So I was U.S. Inventor of the Year in 1997 for my cancer research, discovering a way to kill more cancers than anybody else had come up with before then. I'm featured in a movie called The Immortalists. If you haven't seen it yet, I recommend it. There's some X-rated scenes in there, but it's not me. And actually, when you see who it is, you don't want to see it. You don't want to see that part. But The Immortalists, it almost won an Oscar. It's a documentary on my research and also the research of another scientist that's a colleague of mine who actually has the X-rated stuff. But it made the top 10 of best new documentaries for 2014, but only the top 5 got actually announced at the Oscars. So we got that close. And that's like thousands of new documentaries came out that year. By the way, I'm also in another movie called The High that talks about the research, but it's more about my ultramarathon running. I'm author of 2 books. I just gave them to you. And then, as I said already, I'm an ultramarathon runner, and I'm going to be talking about that because I believe things like that are one of the best things you can do to extend your lifespan and health span. So what I want to do is, because there's a lot of confusion when I go to scientific conferences on aging, I find that a lot of people who are actually big name researchers in the field have some problem understanding what aging is. Okay, and there's this big emphasis on trying to identify biomarkers of aging, things that they can measure in the blood and things like that to know how old you are. Okay, I just kind of think that's a complete waste of time unless you're trying to make small changes in the aging process. If you just want to make somebody have a little more energy, or maybe their hair color comes back a little or something like that, you'll need biomarkers to measure it. But I actually want to do a lot more. So the question is well, what is aging? Is it a disease? I actually consider it a disease. Just because we all have it doesn't mean it's not a disease. And it turns out, as I mentioned later, there's life forms on this planet that don't age. At least they have no detectable aging. And that only enforces the idea that aging is a disease that we all have. And if I had more time, I'd go through the evolutionary reasons of why we age, which I just did at a conference in Las Vegas just a few days ago. So what does curing aging mean? I use this term all the time. That's because my father, when I was 10 years old, said, you know, Bill, since you're so interested in science and medicine, when you grow up, you should become a doctor, find a cure for aging. And he said he didn't know why nobody had done that yet. But years later, when I actually started speaking, I started saying curing aging, and everybody goes, what? That makes no sense. It's like aging is not a disease and stuff like that. But I do consider it a disease, and when we do have it cured, everybody will consider it a disease. Okay, so this whole business of like biomarkers for aging, as I mentioned, I want to ask one question. Is there anybody here that doesn't know which photo of Betty White was taken first? This is what I call radical life extension, radical reversal of aging. I'm not interested in just small biomarkers. I actually want to do this. Betty White is actually a friend of the family's. My father was a television producer before he passed away a few years ago, and she was on his shows a lot. So she actually spent a lot of time at my house and stuff. So I'm very interested in actually seeing it happen with her, and she's like 95 or 96 now. So it would be great. But this is what I call aging, okay? Known biomarkers. We all know what it is. And this is what I call the cure for aging. So how am I doing this? How am I going to focus on doing this? And this is where telomeres come in. And essentially the title of the talk is Bad Things Happen When Telomeres Get Short. There's nothing good about short telomeres. They wreak havoc throughout our bodies, and there's nothing wrong with long telomeres. Long telomeres are always good, short telomeres are always bad. So let's focus on this word telomere, and I know a few of you are new to this, so let me just go through this. To know what a telomere is, we have to zoom in on a human being, and first thing we see is that a human is made up of cells. We actually have 100 trillion cells. That's what our bodies are. It's all cells. If we zoom in on one of these cells, we see that every cell contains a nucleus, and we're really microscopic right now. When we look inside this nucleus, we see all these blue things. Those are called chromosomes. They actually contain our genes, the genes that give us our hair color, our eye color, stuff like that. I'm going to zoom in now on one of these chromosomes, and they're made up of two arms, or maybe a better word than arms might be, I don't know what a better word, but top arm and the bottom arm. Inside of each of these arms is a long molecule called DNA. It's like a string of beads. The beads are called bases, and the typical DNA molecule is like 100 million bases in length, so extremely long. And to fit inside this thing, it's all coiled up like a slinky. Now, along these beads, the sequence of these beads is what makes your hair color blonde or black or whatever, and your eye color and stuff like that. It's the sequence, but it also affects your personality and a lot of things. Everything's affected, of course, by the environment too, but still, you have these genes that play a big role in who you are. Think of this long string of beads now as a shoelace. And I noticed that Alex has this great shoelace thing on her wrist. Think of it as a shoelace, and the caps on your shoelaces they're called aglets. And when they get short, your shoelace falls apart. And the aglets are there to keep your shoelaces from falling apart. Well, our DNA, this all wound up like a slinky, has the same thing. They're called telomeres. So telomeres are the very tips of your chromosomes, the very tips of the DNA inside the chromosomes. And they're about 15,000 bases. We'll unwind the slinky right now. We see that 15,000 bases in length. Remember, the DNA inside the chromosome is like 100 million bases. So the telomere is actually quite small. But it's 15,000 bases only when we're first conceived. And here's why I'm doing all this research, and here's why we're all here, et cetera, is because as soon as your cells start to divide, each and every time your cells divide, your telomeres get a little bit shorter. It's not because something shoos them away. It's just because when your cell divides, you need to make a new copy of the DNA, and our cells lack the ability to be able to replicate to the very end. If I had more time, I would show you videos of exactly what's going on there with bricklaying models and stuff like that. But the point is that every time the cell divides, the new DNA is a little bit shorter. So now, because when you're first conceived, you're a single cell embryo, and when you become a newborn baby, there's so much cell division that takes place to become a newborn baby. Your telomeres will shorten quite a lot as before you even are born. So you're conceived at 15,000 bases. By the time you're born, your telomeres have already shortened to 10,000 bases. That's okay, because that's like cutting off 1/3 of the aglet on your shoelace. Shoelace is perfectly fine still. But the problem doesn't end there, because we have a lot of cell division. We've got to grow up, we've got to heal our wounds, we've got to fight our infections, lots and lots of cell division. And when our telomeres get down to 5,000 bases, we die of old age. And this is something that is not a theory. This is something every lab in the world that works with human cells in petri dish now completely understand, that human cells can only divide a certain number of times. I want you to think of these telomeres as ride tickets at an amusement park. Okay, you're born with a certain number of ride tickets, and every time you go on a ride, you lose a ticket, and when you use up that last ticket, you're dead. Okay, so this is exactly what the telomeres are doing. They're like ride tickets at an amusement park. Every time the cell divides, it's like going on a ride, and your telomeres get a little shorter. Let me go over that again. You're conceived at 15,000 bases, born at 10,000 bases, and die of old age at 5,000 bases. And there's really nothing we can do to stop that yet. We now are able to do things that can slow it down, which is what Isagenix is really good at, but we can't stop this yet. It's going on. It's the only clock of aging that's ever really been discovered, ever. I mean, you'll hear about other clocks like the methylation clock. At the conference I was just there at, there was people speaking about that clock, but it was really obvious to everybody that this clock controls that clock. So that clock turns out to be actually a better measurement of aging than measuring telomeres, but only because telomeres are extremely difficult to measure the length of. But methylation on your DNA, if anybody's heard of that before, that's a good way to measure your biological age. Okay, so I'd said bad things happen when telomeres get short. Let's go over some of those bad things. And the first thing is probably one of the worst things I want to discuss. It's the fact that some people are born with telomeres already short. And this is, if there's nothing else that proves that this has something, the telomere length has something to do with aging, it's this disease. These kids are born with short telomeres. They look normal when they're born, but they die of old age of all the same things that we die of at old age. That includes heart disease, cancer, everything, Alzheimer's. But they die at 20 years old. Okay, so it's like they're accelerated aging, except it's not really accelerated, it's aging at the normal rate, but they essentially are born already at like 80 years old. And so this is one of the really proofs. And if we could lengthen their telomeres, this would be a really phenomenal thing, because I've met some of these kids. In fact, there was a kid, maybe still is, in Isagenix. He used to come to some of the celebrations and New Year kickoffs and things like that I've met. And it would be nice, but even though there's only like 250 kids in the world at any one time that have this disease, curing this would be a real feather in our cap. This is, all my scientists would love to see this disease cured. Now, this is just a publication where you can go read about that. And anybody who wants these slides, by the way, they're available to everybody. But you're also welcome to take photographs of these. I should have said that at the beginning. Now, they aren't the only ones. We all suffer from telomere shortening diseases. This is a list that I made probably 20 years ago. But now, almost every disease you've ever heard of is now connected to the length of your telomeres. So the length of your telomeres control practically everything, including the common cold. But most importantly, cardiovascular cancer, the top 2 killers of people in the United States, Alzheimer's, a lot of different things have been shown to be directly correlated to the length of your telomeres, and a lot of these have been shown now to be corrected by re-lengthening telomeres, at least in vitro. And so there's work being done by my company to now start actually treating people. But the technology, the technique we're using is so expensive, it's going to cost $3 million to treat one person once. Okay, so but we'll get to the bottom of these things and start identifying all these things as being caused by telomere shortening, not just correlated with it. Okay, so to learn more about these diseases and stuff like that, in fact, this is something I want to say, to learn about everything in medicine, you want to quit listening to the hearsay. There's so much hearsay. Press releases, YouTube videos, no offense, except for his are good. Newspaper articles, news reports, they're all hearsay. Okay, some people are just really good at marketing, spreading the word, everybody believes it. Well, if you really want to know what's true, actually there is a video that I've made, a YouTube video, it's the most viral video I've ever done. It's called How to Know What's Real and Not Real. And if you just Google my name and real and not real, you'll find it. And there I tell you how to find out is ibuprofen bad for you? Is aspartame, diet sodas, is that bad for you? Are GMOs bad for you? Is coffee bad for you? All these kind of things. You can find these out by going to PubMed. So PubMed is a database of scientific publications that have been peer-reviewed. They only get published if they're peer-reviewed. And the website's right up there, or you can just Google PubMed. But when you get there, you just type in the word telomere, then and all capital letters, and then heart disease, or multiple sclerosis, or muscular dystrophy, or something like that. And you can see all the papers that have been published about the correlating telomeres to the disease. Now, even though it's supposedly a database of only true papers, a lot of bad ones slip by. So I recommend doing what's called a meta-analysis. And if you read my book, you'll see I've done a meta-analysis in the book regarding cancer, which means looking at a bunch of the papers and seeing that maybe 1% of them say one thing and 99% say the other. Go with that 99%, because the people that want to spread the hearsay and market products, they'll go with that 1%. Okay, and that's why a lot of bad information is spread. Okay, so I've been describing this big problem. Bad things happen when telomeres get short and stuff like that. Let's talk about the solution. Well, it turns out, I've been saying that our telomeres get shorter every time our cells divide. But if that was true, we would be extinct already as a species, because reproduction requires cell division. And if our cells, it's like when we're producing our sperm and our egg, if the telomeres in those cells got shorter, our children would be born with shorter telomeres than we have. Their telomeres would be born with shorter telomeres than them. And we wouldn't have any chromosomes after maybe 3 or 4 generations. So this is what I did back in the early to mid 1990s, is I was studying why is it that our reproductive cells don't have telomere shortening? What's going on there? Why don't they have telomere shortening when all the other cells in our body do? Well, as I said, aging doesn't occur in our reproductive cells, and we showed that telomeres don't shorten in our reproductive cells. Why is that? Well, in that research, in about 1992 or 1993, I discovered this enzyme telomerase. And I don't like using the word I like I just did. I always got to qualify. I had a team working under me. I was leading the team of about 30 different scientists. The 100% focus was trying to find this. People all over the world were trying to do it too. And some had been working for years longer than we had, but we were the ones that discovered this in about 1992 or 1993. This green squiggly thing here is the DNA, now shown as that long string of beads, but it's shown as a double helix. And telomerase is shown as a factory there that actually binds to the tip of the chromosome and lengthens it. Okay, so the lengthening is occurring in our reproductive cells, but the shortening is also still occurring. So I want you to think of lengthening and shortening as kind of a tug-of-war going on inside of our reproductive cells. And it's a tie, okay? Our cells divide, the telomeres get shorter, telomerase re-lengthens it. It gets shorter, re-lengthens, shorter, re-lengthens. Okay, so it's a tug-of-war, and I'll come back to that analogy too when I start talking about isagenesis and things like that. But for some reason, and I mean, I think I know exactly why, but it'd be too long. It's an evolutionary reason. As soon as we are conceived, we shut this enzyme off. This enzyme is turned off so that our telomeres get shorter. Bottom line, long story short, it actually is a species is more successful at surviving a rapidly changing environment if we get rid of the old in the species. So it's not good for each of us, but for our whole species, it is. The reason we're all here right now is because our species has been very successful at surviving a rapidly changing environment since the beginning of time, practically. And we did this by killing off the old so that the young can compete. If the old never got feeble and stuff like that, the young could have never survived in mating and things like that. And as a result, we wouldn't have passed on our genes and we would have been extinct a long time ago. That's why we age. And I just did a whole hour's talk in just 30 seconds there. So the question is, so it's in our reproductive cells. What happens if we produce telomerase in all of our cells? And I mentioned I was going to come to this before, but there are actually animals on this planet, like lobsters, that have no detectable aging. And this was actually the first one that was discovered. And people didn't know this a long time ago because before Darwin, nobody cared about animals. Nobody even thought about that kind of stuff. After Darwin, people started saying, well, let's see how long animals live. Well, they don't have rings on a tree like trees do. So they had the only way to know how long they live is to be there when they were born, put them in a cage or an aquarium and watch. Well, 150 years later, lobsters are still showing no signs of aging. Now it's been shown now that they actually have telomerase in all their cells, not just our reproductive cells. And a lot of people, when I first started, and it's less now than it used to be, a lot of people used to say, when you produce telomerase in all your cells, you're going to make people very sick and unhealthy and stuff. Because why would we shut it off unless it was bad for you? So it turns out that these animals never get sick. They rarely get cancer. They rarely get other diseases. They die, they get eaten, and every year they shed their shell and they're a little bit bigger and they find it harder and harder to find places to hide. So they still have a tendency to be knocked off as they get older because they're easier prey. But they just don't get sick. The only way they die really is from predators or a virus infection or something like that. But it turns out now they're not the only ones. You know, people have always known that tortoises live a long time, but now still nobody can find anything. Clams, humpback whales, some fish, and some birds, all these animals have no detectable aging. Charles Darwin actually had a pet tortoise named Harriet, and Harriet just died recently at 180 plus years old from some infection she got. It wasn't aging at all. Humpback whale was found with a harpoon in it already. They carbon dated the harpoon, and the harpoon was 130 years old. So the whale was older than that. Now, I did say that none of these animals have rings on a tree that you can count, but clams do. If you look, clams, they have these stripes. They get a new stripe every year on their shell. And so when people started realizing that tells you how old a clam is, they started counting the stripes, and now they found clams that are over 500 years old. All these animals, and now there's been sharks that have been found to be over 500 years old too, because they're measuring their age by something in their eyeballs. Something I can't remember what it is, but all these animals, they have telomerase produced in all their cells. They have no telomere shortening. They have no detectable diseases hardly at all, and it's what I want us to be. Okay, so that's where we are. So, what about humans? Well, here's the plan. This is we were doing this for a while, but then one day, good old John Anderson came here, sat in this room. He and I sat for hours talking about a plan to come up with a way to lengthen telomeres. Now remember, this is where I'm going to say the tug of war. Okay, so we are still working on it, and I'll be mentioning that in a second, but humans are still losing the tug of war, but at a slower rate. Now it turns out, and if you read the book, there's a good explanation, is our shortest telomeres actually still get longer and it's really hard to understand why that would be, but that's the reason why people are, or probably one of the reasons, because we haven't done actually studies that show this, why a lot of people are showing some age reversal kind of stuff from isagenesis, like age spots disappearing on hands, vision getting better, athletic performance, endurance getting better, things like that. Even though it's not turning us into 25-year-olds yet, okay? But John and I are still working on it. So let me show you how we're doing it. Okay, so this gray bar here is the DNA again. This is inside of a cell. And there's an example of a gene. You know, remember genes give you a hair color, eye color. In this case, this is a gene that produces telomerase inside of our cells. And next to every gene is a regulatory element. That's like a light switch. It's an on-off switch, except it's more like a dimmer switch. You can really control how much telomerase gets through by that regulatory element. Every gene has one of these things next to it. We have more people coming in? Hi. So now this turns out this is the way it is in our reproductive cells. In our reproductive cells, the gene is turned on and it's producing telomerase all the time. When we are conceived, a protein comes along and binds to that regulatory element and completely shuts it off. Completely shuts off the gene. And so in all of the other cells of our body, we do not make any telomerase, and as a result, our telomeres get shorter. So what John and I are doing is John sends us thousands and thousands of natural product extracts that he's all over the world. I'm calling him up sometimes. He's on some mountainside in Mexico or something like that, picking some plant that nobody's ever tested before. This is what John is. I mean, he's a really remarkable person. I don't know, anybody here met John Anderson before? Okay, he's a very amazing person. So he and I are, he's making these extracts. He sends them to us thousands at a time, and we add them to cells. Oh, by the way, that protein's called a repressor. We add it to the cell. It's like this green thing, and it dislodges that repressor. And so now, not everyone does it, but we have these high throughput robots that I'll show you during our tour that can test up to like 10,000 different natural products a day. John can't keep up, so John's the bottleneck. John can't send us enough to keep the robot busy all the time, but we've already tested, as I'll show you, lots of these things. Every once in a while, we find one of these natural extracts that will actually get inside the cells when you swallow it. Get inside your cells, bind to that repressor, dislodge it, and turn the telomerase gene back on, and that allows the telomeres to get longer. Now, as I said, it doesn't completely dislodge it like it does in this photograph, but we're still working on finding more and more potent ones, and we've actually made a lot of progress, and that's why there's is it the fourth generation now? Okay, I can't remember.
He's calling it the fifth.
Okay, so
Upregulating or downregulating?
this would be called upregulating. Yes, that'd be upregulating, but we're not completely upregulating it to the level of our reproductive cells. Yeah. Okay, so we're looking for these green things, and this is a picture of our robot. This is me and one of the scientists working there. But it's not just the robots. There's a lot of work, cell culture work, lab bench work, lots of different things. So this is a very big operation. We're actually 10,000 square feet of lab space here, because it's a big ordeal. This is not easy, and this is why we're probably the only place in the world that does this. Okay, it's because it's not easy, and fortunately, John Anderson decided to give us a shot at it, and we've been very successful. So this is actually more details of our robots. We have two of them. This one here, that's from this guy to here is one robot. From behind his back to the other guy is the other robot, and I'll show these to you when we do the tour. Yeah, so don't expect humanoid-looking robots. A lot of people say, "Where are they?" No, right there. Okay, so we have now tested, well, no, we've gone way over this now, but when I made this slide, we had tested over 10,000 different natural products that John Anderson had sent us. We identified 39 that induced telomerase, which meant that it dislodged that repressor. Some dislodge it just a little bit, some dislodge it more, and some more than others. Okay, so we 39, I think they put maybe the top 5 or 10, top 10 into isagenesis. And that's what this is here. Now, I've just learned at this conference I was at just this a few days ago that they've changed the bottle. I didn't know that.
Yeah.
But so you guys are getting a new bottle. I have not seen the new bottles because we have so much of this in stock here. All of our employees get it for free. But I also, I highly recommend, I'm a big fan of a lot of Isagenix products. I think Complete Essentials is a really good thing because this might induce telomerase to lengthen telomeres, but this gets rid of people on the other side of the tug of war. So it gets rid of the shorteners. So the Complete Essentials has things like antioxidants, anti-inflammatories, things like that that actually remove people from the shortening side of the tug of war. So taking both Complete Essentials with Isagenesis is, I think, the way to go. But shoot, I think there's no products that they make that I'm not a fan of. And I got to admit that one of my favorite products now is eShots. I mean, it's like when I speak at a conference, I don't get on stage before I take an eShot because I think it has adaptogens in it, so you don't get the shakes like you do with coffee and caffeine.
Give you some mental clarity.
I take one at the 10th hole.
You take what?
I take one at the 10th hole when I'm golfing.
Yes, well, yeah. That's better than the 19th hole.
Yeah.
Do you want us to hold questions to the end? 'Cause I
No, go ahead.
I have one other question about when you were talking about how it'll lengthen some of the shorter telomeres.
Yes.
Do you think that that's if we're prematurely shortening or accelerating the shortening, that maybe our biological age is bringing it back to our biological age?
No, it's
Perhaps?
nowhere near that. It's easier if you. I forget what page it is, but you'll see pictures of tug of wars in the yellow book, and it shows what it does is it's as if the people that are pulling to shorten are falling off a cliff. So the shorter the telomeres get, the fewer people that are pulling on it, and so that means only less telomerase is needed to win that tug of war. But then when it starts winning, people come off that cliff and get back on the ground and start pulling again to shorten. So it has nothing to do with our biological aging and stuff like that as much as it has to do with just the Isagenesis inducing telomeres. Okay, so where was I? So I want to say, and I think I've already said it, is that we are screening again. We are actually now, and I'll show you the lab where John is sending us natural products and stuff like that. And so what I want to do, so that's pretty much about Isagenesis and Isagenix products. I want to talk a little bit now about things you can do, what else, in addition to Isagenix and Isagenesis, what else you can do to help keep your telomeres long. Okay, there's nothing, that's not mine because I don't have mine. There's nothing that exists that will lengthen telomeres. Isagenesis is probably the best you can come up with. But there's things you can do to decrease the rate of shortening. And what I want to do is I want to first mention yoga. And for those people who live here in Reno, there's actually 2 yoga instructors that are very versed in telomere biology. And I've spoken at a lot of yoga meditation conferences showing that people that do yoga and meditation have longer telomeres than their friends their same age that don't do yoga. Okay, yoga is it de-stresses you, decreases inflammation, etc. And so I highly, so both these instructors, Katie Luvat and Leon Maynard, they're both at the Yoga Center in Midtown. But I think the one that's most successful at keeping your telomeres long is called Yin Yoga that Leon Maynard does. And for those of you that feel like yoga is a lot of work, Yin Yoga is like almost you fall asleep doing it. Okay, it's a way of de-stressing. It's kind of like a meditation, but doing yoga. And I go through her classes all the time, and I'm always shocked at how few people there are, because everybody wants to be jumping all around doing a lot of exercise, and this is the exact opposite. And it bothers me is I say this at every one of these meetings, and not a single person, I've never seen a single person from any of these talks actually show up. So people, come to these things. This is really good for you. These 2 instructors are, as I said, very versed in telomeres, and they can help you keep your telomeres long. Something else that I recommend is when exercising, don't be this runner right there, okay? This is actually, he's doing himself a tremendous disservice. He is pushing himself too hard. This is bad for you. It causes inflammation, and it causes oxidative stress. All these things accelerate your telomere shortening. And so this is why a lot of times people say running is bad for you, because they're looking at those type of people that really push themselves. What you want to be is you want to be like this guy, who you might recognize. This is the way I run. This is a race that I'm running in the Himalayas of northern India, and I ran for 52 hours. That's all day, all night, all day, all night, and 3 more hours. And I never stressed myself. Maybe I got a little tired, but this is me coming up to the 97-mile mark here. But you want to be having fun. Okay, I always say, if running or kayaking or biking or whatever you do quits being fun, then quit. Okay, save it for another day, because you're only doing yourself an injustice. Save it for another, and you're going to find out if you take that kind of attitude, you just get better and better and better. Okay, I am personally right now, I never push, I never race, I never try to win or anything like that, but when I turn 70, I have every intention of breaking the world record for the 100-mile distance, because it just seems so easy. I break it every time I run now, when I run 100 miles. So it's like, but that comes from just not pushing it, taking it easy, just getting good at it. Okay, so I would like to recommend that people get into doing some activities, and there are some races in town that actually, and I'm going to say this in a second, are meant for walkers. They really encourage walkers. That includes what's Dirty Wookie race. It's a 10K race, 6.2 miles, it's later this month. Wobble Before You Gobble, 10K, 5K. That's for Thanksgiving. And that's November 28th. That doesn't mean you can eat a lot, though, during Thanksgiving. Then there's also the Biggest Little Half Marathon, and they also have a 10K and a 5K race on May 30th, 2020. And that's all Desert Sky Adventures. And that's their website. You can sign up for these races. But the key thing is, they're the only company in town that I know of that really encourages walkers. Okay, and this might sound like a sales pitch, but that's my wife's company. And I think that's one of the reasons that she is so into encouraging walkers, is because I'm so into it. And I encourage people to get out there and walk, because walking is just as good for you as running. You actually burn just as many calories per mile walking as you do running. It just takes you longer. Okay, so she and I have at times been crewing people that were like maybe an hour behind second to last place. Okay, just because we wanted them to finish. Okay, so never worry about that. Come to these races. I highly recommend it, and it's going to help your telomeres, unless you're like that first runner I showed you. Also, if anybody's looking for a good anti-aging doctor, we have actually one of the best that I know of here in Reno. His name is Dr. Mark Gunderson. He was actually just a speaker at the conference that I was at last weekend. He's a very, very knowledgeable guy, and I highly recommend him. He's Reno Age Management Institute here in Reno. Then the conference that I recommend, if anybody, there's a lot of conferences on aging, but this is the best by far. And again, it's going to sound like an advertising. I'm one of the organizers of this, but I'm also head of the charlatan police. Okay, we do not allow charlatans to speak at this conference, and all the other ones do. So this is like, if you've heard of A4M or AMMG, I've spoken at those conferences a lot, and I'm shocked at the number of charlatans that are on stage speaking before or after me. This one is really good. We just had it. It was just a few days ago. So the next one won't be until 2020, unless you want to go to Asia, because there's going to be one in Asia really soon too. But it's a very successful, and they actually are, the videos from all the speakers are available today, is what I think is, they're going to be available today if anybody really wanted to go check that out. Then I also recommend the books I've already given you, except I'm showing Curing Aging there instead of the Quest to Cure Aging. And they're available on Amazon.com. I also recommend the following books. Dr. Caldwell Esselstyn has written, I think, was the best book on reducing inflammation. It's not a pleasant thing. It's like, but it's my lifestyle. It's what I follow. It's totally vegan and no oils. This is one of the things. Hearsay says oils are good for you. They aren't. olive oil is not good for you, canola oil is not good for you, sesame seed, none of those oils are good for you. They're the most calorie-dense foods there are. They all cause inflammation, and so they recommend, so Caldwell Esselstyn recommends no oils at all. Now, I'm good friends with, who eats at Grateful Gardens here? Yeah. Well, I'm good friends with the owners, Julie and Gino. Yeah, and I just had lunch with them 2 days ago, and they told me they are also now on the Caldwell Esselstyn diet, vegan and no oils, and they are going to start soon having foods that are more towards that kind of lifestyle, which would be the only company in the world that I know that focuses on that. In terms of inflammation, this is a plug I just put. My brother, this is my identical twin brother. He used to look 10 years older than me, very out of shape, didn't lead my lifestyle at all. But then he started having some very serious medical problems, cardiovascular related and stuff like that. So I got him hooked up with Caldwell Esselstyn. And now he has started a group on Facebook called the Squeaky Vegans. Squeaky for no oil, okay? So Squeaky Vegans on Facebook, it's getting quite a lot of attention. And if you want to see pictures of him before and after, and then compare it to my Facebook pictures, you can see like 20 years ago, you could not tell. We can't, when we look at photographs of ourselves, we can't tell each other apart. Okay, we're that identical. Now we're just, well, then we got really different. Now he's coming around. This is actually not one of the more recent pictures, but you can see some pictures where he looks pretty much like me now. But I also recommend something called the OutCat test. It's a test that you can get, just Google it or get the slides from me and go to that website. It's a test, it's a blood test where you can have your blood tested for sensitivities to all kinds of foods. Now it's not allergies, okay? It's not an allergy test. That's an IgE, which is one kind of immune antibody. This is checking for IgA, which is another kind that actually will cause inflammation, especially in your blood vessels, increase your risk of cancer and stuff like that. You can learn what foods you can eat and what you can't eat by doing this test, and I highly recommend it. Then lastly, this is new. This is a book called The Kaufman Protocol. It's written by Dr. Sandra Kaufman. And I'd mentioned that we have clinical studies going on right now which cost $3 million per patient. When I read this book, and I've read every book that's ever been written on things for anti-aging, I thought this was by far the best book I've ever read. She wrote it, not me. And I recruited her to our clinical study as a result. So she's now a principal investigator on our clinical study, and she was also a speaker at this last conference. But that book is a phenomenal book. There's nothing like it. Nothing comes close. And it's easy to read, very well written, and it's actually got formulas and stuff like that where you can figure out what's the best supplements to be taking. It's really good. There might even be a copy sitting back there. But I think she's 90% of the book she sold is because I promote it, and I don't get any compensation. When I find something I like, I promote it. So. Now, a lot of you have seen this, so don't say anything. People often ask, why am I so obsessed with curing aging? Okay, and it's like, especially when I was speaking in India, it's like everybody in India, it's like, this is awful that I'm so concerned about aging. They would ask me, am I afraid of dying? And you know this, because you're from, oh no, you're from Colombia, that's right. But in fact, in Colombia, everybody's the opposite. Everybody wants to live forever. They're very much more party people. So I always say, I'm not afraid of dying. I mean, I wouldn't run all night long with possibility of being jumped by mountain lions and things like that if I was afraid of dying. Okay, what I'm afraid of is missing out. There's a lot of great things that are going to happen in the future. Okay, and we hear about it all the time, and I just don't want to miss out. And this is a scene from Star Trek First Contact. Okay, this is James Cromwell, you might recognize him, playing the role of Zephyrin Cochrane. Zephyrin Cochrane is the future discoverer of warp drive, the ability to go faster than the speed of light. So he goes faster than the speed of light, and then this alien race that they had never met before called Vulcans detects that. And so they come to Earth to meet the person that figured out how to go faster than the speed of light. And this is first contact, first human meeting a Vulcan. And this is, of course, fictional, but when this really happens, I want to be there. And I want you to all be there too. So I just want to announce that we just had our 28th anniversary. This is actually this room here. This is most of the employees, not all of them. But we are celebrating our 20th year anniversary just last July. So the logo for my company, and we've been studying telomeres now for more than 20 years. And thank you very much. And ask away. I can answer. If anybody has to leave soon and would like to do a tour pretty quick, we could do that. But do you need to leave pretty soon? Okay. So, but why don't we go and ask questions until people run out of questions? Yes.
Dr. Andrews, I just wanted
Bill,
to say,
don't ever call me Dr. Andrews.
You've always told me that. So
Yes.
It's hard though. 'Cause
I am a doctor.
Yeah.
But I am a PhD doctor. But I just I just wanted to cure aging, and one day they just handed me a PhD. You know, it's like that wasn't my goal. But go ahead.
Okay, so Bill, so this is Brent Nally speaking. This presentation, and hopefully if we have room and if it's not too inconvenient, I've already done the walkthrough of all your lab on my YouTube channel, but I'll try and get that again. But what I want to state is, first of all, thank you so much for doing this. And Dr. Kaufman was so, she likes to be called Dr. Sandy, by the way. She said that
really?
on my
Okay.
YouTube channel, yeah. And she was so phenomenal. I did an interview with her. You were saying goodbye. But we learned a lot of great things, but it'll be on my YouTube channel as well. So if you guys want to see this, I have everything will be on my YouTube channel. It's just Brent Nally, and then Dr. Kaufman will be on there as well.
It's just I can't say enough. She is amazing. Okay, and so he interviewed her at the RadFest. He was interviewing for her so long that everybody was leaving, okay, because it was closing down. But I can't wait to see that interview you had with her.
It was really good. We had a lot of fun. She's a great personality. And my name is Brent, B-R-E-N-T.
And how's Allie spelled?
Nally, N-A-L-L-Y. N is in Nancy. And yeah, Brent, B-R-E-N-T, Nally, N-A-L-L-Y. And this whole presentation, everything will be on my YouTube channel.
Yeah, was there anybody you didn't interview that was in?
There was a lot more that I wanted to, actually. Ben Gortzel, I've been a huge fan of his for many years, and I got to chat with them, and we'll be interviewing them soon.
Yeah.
But not Ann, it's just Brent now, that's my name.
So his website's the go-to place to learn about aging. Any other questions? Yes.
When you said no oil,
I know, I
a
was
record
like-
scratch for me. So how do you make hormones with no oil? I mean, where are you?
Well,
Isn't it
like
so lining?
I do believe you have to do the omega-3 fatty acids, okay, and some of the omega-6s, unless the oil has some benefit to you, like most oils are inflammatory, whereas a few of them are anti-inflammatory, like the omega-3s and GLA, one of the omega-6s, is anti-inflammatory. Yeah, but so you have to take some oils. Okay, so I take fish oils, but I don't even get mine from fish. I take a synthetic EPA, which is one of the omega-3s. The EPA gets converted into DHA, so I have that too. And then I get my ALA from plants. And so I've got
Flax and borage, right?
actually a lot of plants, but I do flax seeds every morning. And I found out that I actually have to take more than that because flax seeds don't give you enough ALA. Okay, and I was piling it on top of my cereal and still not getting enough, or my oatmeal at least. All right, next, any other questions?
What about nuts?
Nuts have oils in them too. So you know, cashews are not nuts. Those are beans. Okay, so you can eat cashews, but nuts have too much oil in them. So I totally avoid nuts, but of course occasionally I'll have some.
Coconut oil.
Coconut oil is actually one of the worst oils there are. It's gotten a lot of publicity as being a cure for Alzheimer's disease. All that was charlatan stuff. In fact, some woman claimed to have cured her husband of Alzheimer's disease and wrote a book and was marketing the book, and she never mentioned that her husband passed away from the Alzheimer's. Okay, it was like, it's just complete charlatan stuff. Coconut oil is the worst oil. The other one that's really bad for you is avocados. Okay, avocados are really bad for you. They're very
Oh my
rich in.
God.
Very,
Everybody say that they're very healthy. I used to eat it.
I used to love avocado, but I don't eat them anymore. What was your question?
With the Isagenix shakes, the formula that comes from the package, if we add vitamins to it, vitamin C's, oils, kale, things like that, does it decrease? Does it alter? Does it change it?
I couldn't answer that question nearly as well as John Anderson could, but I add a lot of things to it. Okay, I buy the shakes by the big box full. I mean, John, I'm probably not supposed to say this, but John, because I'm an ultra marathon runner, I need lots of protein. But I mix it with lots of different things. Yeah, I can't imagine why adding something like that would be. If you add too much, it just comes out your pee. You know, so it's, you don't have to really worry. Any other questions? This is okay.
Can you answer
Candace.
one of the big sort of controversial things that come up is there's no organic label on any of these products.
There's no
It doesn't
organic
say
label.
Organic.
Only on the greens.
But they're all
Only on the greens.
they're all organic.
But how when it doesn't say it on the label? And
Oh, I
someone
don't
says-
know. So I'm the wrong person there. But this is news to me. It's like
Because the ingredients, those botanical ingredients are coming from around the world, and if they're not certified grown organic with those practices,
Yeah, they can't.
then you can't put that label on. But what's most important about organic is it clean? Is it free of pesticides, herbicides,
So you just
fungus,
don't do
so
testing.
you just need to know how clean it is, that's what's most important.
A lot of things are labeled organic and they have pesticides and bad
yeah,
things. That's-
I know there's a lot of misuse
So
because
it's actually cleaner and better than organic for what people are looking for.
I'm just wondering.
Yeah.
the FDA has this thing about if the toxins are below a certain level, you can say toxin free, but it's per level. It's level per serving. So sometimes you'll find these bottles, and to get their levels below, they'll say this is 20 servings. When you would think, God, that's less than one serving. Okay, but I know John Anderson, and I know, like for instance, the protein that's in the proteins all comes from grass-fed cows and things like that. He's very organic-minded. I don't know what. I've never been asked that question before. I wouldn't know the answer, but I've always thought it was all organic.
It's probably so that Isagenix doesn't get in trouble with the FDA for labeling. It's probably more a labeling issue.
I can tell you that's how they came up with the dose. I mean, Isagenix didn't calculate a dose, and that's why it says 2 capsules. The FDA just automatically puts that on everything. 2 capsules in the morning, 2 capsules at night, and I just was shocked that there was no.
You can take more.
Yeah, I know. Well,
I do.
I know football players that take a half a bottle every morning and a half a bottle every night.
Oh my
Yeah.
God.
And they've been on stage at Isagenix announcing that. All right.
The sugar is too bad for you because I
Sugar
love sugar.
is high, but it's okay as long as it's balanced with the fats and the proteins. Okay, so what's good about the Isagenix shakes is the balance of fat, protein, and carbohydrates, and especially free sugar. So it's okay there because your body uses the sugar differently in the presence of fat and protein.
But I say
That's a
another-
big thing for me that I
I
had
say,
to.
but the other pastry, I love that.
Say it again?
The pastry.
Pastry? What pastry?
All the sweet candies, all
Oh,
kind of cakes.
I thought you meant
whatever.
Isagenix was making a pastry.
No.
Yeah.
The other is too bad for you. The other kind
No,
is
if Isagenix was making a pastry, I would like to try it.
Oh,
Okay, 'cause I'm sure it's
I
going to be
would
the
like
best.
You can put the protein shakes in pancakes and make chocolate pancakes.
Actually, Taylor, Molly's daughter, she's done that. She's actually made pancakes for big parties that were made from protein shakes from John Anderson.
Oh, yes. Okay, that will be good.
You always do such a good job of answering the big cancer question. I still come across people that are afraid to try it because they're afraid the timer will turn the cancer.
Yeah.
cells.
Okay, I have a recommendation. Let me see if I can bring up another slide that would help me with this. Where did I show that? Let me just think. Oh yeah, I just showed that. I get blinded. Let me just. This is a really good question because there are a lot of people in the world that like to go around and say things that aren't true. It's all hearsay. And it's best described if I can find this presentation. Let me just, reopen this, darn it. So this is my RADFest presentation. And I gave a short discussion about cancer. Oh, shoot. Wait. Or did I? Oh, yeah. Okay, this one here. Okay, so. Okay, so you know, as I said, I was National Inventor of the Year for my cancer research. I know a lot about cancer. And I know that a lot of people, almost everybody that's saying that telomerase causes cancer, have no cancer background whatsoever. Okay, so what I wanted, this is where at the conference I just spoke at RADFest, I talked about cancer, and does shutting off the telomerase gene decrease the risk of cancer? Actually, does so. Does giving yourself telomerase, does that increase your risk of cancer? Is another way of saying that. There's absolutely no data in any scientific peer-reviewed journal study. And let's see, I'm caught here. I think. Okay, so I already talked about evolution. A lot of people say we shut off telomerase to prevent us from getting cancer. But if that's true, it's failing because we're getting cancers at very high. I've had 5 friends die of cancer just this year. Yeah, it's just, now, the people who don't know what they're talking about, they'll say that okay, in evolution, I was saying, you know, we kill off the old. We want to kill off the old because the young can compete, or the young don't have to compete with the old for mates and food and things like that. So. So the goal here is to pass on your genes. In an evolutionary sense, the more successful species is the one that's going to be able to pass on its genes and shuffle their genes the most. Okay, well, in pre-humans and stuff like that, we did that before we were 20 years old. Okay, we'd already raised our children before we were even 20 years old. And it turns out if you get a cancer before you're 20 years old, your telomeres are long enough that cancer will kill you without ever turning on telomerase. Okay, your cells will divide enough times because it's got that many ride tickets essentially still on the hips, that cancer will become the size of like half your body before it'll get telomere shortening. So again, it doesn't make any sense. This whole idea that telomerase causes cancer is just a theory that by some people with no data supporting it at all, and actually there's lots of data arguing against it. Oh, and when I said no data, there's actually, for every study that says that telomerase might cause cancer, there's 99 that says it doesn't. It actually reduces your risk of cancer. Short telomeres cause mutations. Mutations cause cancer. This is one of the main reasons that we get cancer when we get older is because our short telomeres cause all kinds of mutations, including chromosome rearrangements and stuff. Those all cause cancer. Okay, the bottom line is the lack of telomerase is far more likely to cause cancer than telomerase is. We already get cancer at high rates. People don't get it, okay? But here's the thing, is that I would recommend, so you've got this book. There's a chapter in here that's called Telomerase Does Not Cause Cancer.
Can you go back to the last slide?
Oh, yeah, because I can make these slides available too, but
Yeah, that's true.
I think I can. RADFest might not want me to because they're trying to sell the video. But there's a chapter in this book called Telomerase Does Not Cause Cancer. And this video, it's on my website. Just go to my website, www.sierrasci.com. It's a presentation I gave in Tokyo that's about an hour and a half long. But if you begin at 25 minutes, 25 seconds, you'll hear me start to talk about cancer. And the reason for this is because this was in 2017. Big conference, a medical conference. Every person in the audience was a medical doctor, 500 plus in the audience. And they all came to hear me speak. And the night before my presentation, Elizabeth Blackburn, who is one of the people that tried for years to discover telomerase unsuccessfully, and then she got really upset when I discovered it. Because she'd been working on it longer than I had, she got the Nobel Prize. okay, instead of me, which I understood. I used to tell people, I'm not going to get it, she's going to get it, because that's the way the Nobel Prize works. But her background was working on a pond scum organism called Tetrahymena. She had no cancer background whatsoever. She got into cancer after I discovered telomerase and showed that we could kill cancer cells by inhibiting telomerase. But the reason why inhibiting telomerase killed the cancer cells is because it forced them to die of old age. But she started this whole thing. Well, if inhibiting telomerase kills cancer cells, then telomerase must be the cause of the cancer. There's no data. She has no cancer background. So the night before, she got all over the news talking about this. I heard something like 10 o'clock the night before, 10 p.m. I stayed up all night and put together a great presentation beginning at 25:25. I go through the whole reasons why this is all not true. It's probably the best account you can find anywhere of why telomerase does not cause cancer. I recommend you watch that. Let me see, is there another slide? Okay, so I believe that we shut off telomerase not to prevent cancer, but to ensure death to the old. And so that's the subject about cancer. But I highly recommend, if you didn't get those, the Tokyo presentation 2017, it's on my website at 25:25. Or the chapter in the book is the same thing, but not nearly as detailed as the video. And plus, some people like to watch the movie instead of read the book. Yeah.
Can you tell? I've noticed a huge change in my athletic performance.
Yeah, that's exactly.
And I think you noticed the same thing.
Yeah.
Especially at high altitude.
Well, I've always been high altitude, but right after I started taking Isagenesis, which I think was before anybody else did. Okay, John Anderson and I started taking it before it was even available. I was running ultra marathons every month, and that's I go through withdrawals if I don't do one at least once a month. And then so I've been doing them for years, and always been slow runner, stuff like that. And then I ran this race on Antelope Island in Salt Lake City, and I just what the hell's going on? I feel like the wind's pushing me on the back, and I'm running. I know all the other runners because I see them at all the races, and I'm running past them. I'm going like this. I don't know what's going on. And I finished in 9th place overall, won my age group, first time ever, and 9th place out of over like 200 runners, okay? And I'm like, what the hell happened? How did I do that? I'm driving home, and I'm suddenly realized it's the Isagenesis, or it was called Product B then. And I've noticed that I've talked to a lot of athletes, including Susan Sly and others. I don't know if people know Susan Sly, but she's a marathon runner, stuff like that. One of the things that a lot of people notice is their endurance getting a lot better. And I've never gone back to being the runner that I was before I started taking Isagenesis. So it makes a really big difference. But I think it's from lengthening the shortest telomeres, not lengthening all the telomeres. Okay, so that just the shortest telomeres is causing something that make your endurance better. So,
Bill, back
yes.
to the cancer and telomerase. You know, I think people should know about Liz Parrish and what she's done in
yes.
relationship with her, and why she had the confidence on September 15th, 2015, to go down to Bogota, Colombia, and take the gene therapy that you gave her that she scaled up.
Yeah.
The telomerase gene therapy. She did a dual gene therapy that day. She also took a myostatin inhibitor. But you know, after she announced this, I remember the internet. It was an uproar. People saying, "Don't you know telomerase could cause cancer? You're irresponsible," and this and that. Well, guess what?
No
we now have a human who's done this. We now have another one, and it's been just over 4 years. We just saw her. She's 48 years old. She'll be 49 in January. She looks great.
Yes, she looks younger than I've ever seen her. I tell you, when I saw her this time, she's.
And she only did that because all the animal models of gene therapy, for telomerase gene therapy, shows it dramatically increases their health span and their lifespan. So they're not just living longer in a decrepit state; they're staying very young and healthy. That gave her the confidence to do that. All the studies she read. So we're moving beyond just writing papers and arguing it out. This is happening, and it's happening in a person. So if she gets cancer in a few years, then maybe we'll be back to the drawing board.
No,
she looks great.
Yeah, and this is another amazing person, Liz Parrish. She was a speaker at RadFest too, but she's a lot braver than I am. Okay, she treated herself with gene therapy that we gave her, and I actually told her, don't tell anybody where you got it from, because if she died or something like that from some unknown thing, because it was venturing into the unknown, so who knows what's going to happen. I was afraid we'd get in trouble. It was only last year at RadFest that I finally agreed, because people were saying that they didn't believe she really did it.
Right.
So I got on the news and I said, yeah, she did it. I'm the person that gave it to her, including the follistatin. I gave her the myostatin inhibitor. She got that from us too. But I'm glad she did it. I didn't know what the results would be, but I'm glad to see now that she is actually looking younger than I've ever seen her for.
And not just looking younger, all of her biomarkers have reversed dramatically, including telomere length from life length and spectral cell. Her telomere length was shown about an age of 60 biologically when she was 45 in 2015. She's been measured twice. The last one was about 30 years old. And when my wife and I went to interview her at her home on July 10th.
Oh, you've been to her home?
Yeah, so that interview is on my YouTube channel as well. I highly recommend you guys check it out. It's about 2 hours, a lot of details in there. I just interviewed her director of global outreach, Andrés.
Yeah, Andrés Grases.
Yeah, Monday morning. That will be on my YouTube channel soon. But when my wife met her in person, my wife knows all this stuff because she's married to me. She doesn't watch all this stuff, but she gets the high level. When we left, she said, she kind of looks like one of our friends. I'm 34, like age.
Yeah, no, she looks like she's in her 30s.
Yeah.
No, she's 48,
She'll be
about
40
40.
now in June. The skin up close, not makeup, because I'd never met her in person until then. So you watch it on TV and makeup, and you're like, but up close in person. So
Well, she and I have been friends for 10 years. She and I actually were working together a lot. She's been here a lot. We formed a company called BioViva Fiji together to try to promote the gene therapy. This is a $3 million treatment that we're talking about. She found a way to cut a few corners and or get it done at a cheaper price, but she still got the $3 million worth treatment. But so we actually had to go our separate ways because I signed a deal with Labella Gene Therapeutics, and she chose not to do it. But we're still good friends. And I want to say one thing. There's no such thing in my field as competitors. Anybody working on trying to cure my aging is working with me. Okay, so some people think Liz Parrish and I are now competitors. Not true at all. Okay, some people think me and Aubrey de Grey are competitors. Not Aubrey. Aubrey de Grey is another big name. In fact, if you watch The Immortalists, he's the other co-star in the movie The Immortalists. But it's like we all work together. I've never seen an industry like this. The ones that are the competitors, they're the charlatans that aren't. They're trying to sell something that really doesn't work, because the only way they're ever going to sell it is to discredit us or something like that. But Liz Parrish, Aubrey de Grey, Sandy Kaufman, a bunch of other ones there, and they were all at this conference. We all feel like we're working together to cure each other's aging. Because I'm in this to cure my aging. That's how I got started. Yeah, Alex. Well, Malcolm also had his hand up, but Alex first. Go ahead, Alex.
All right, I was just curious about telomerase and stem cells.
Well, there's another rumor going around that stem cells produce telomerase and they don't have telomere length, telomere shortening. That's not true. The reason why some people think it's true is because when you take any kind of cell, including a stem cell, put it in a petri dish and make it divide really fast, that repressor can't keep up with the new DNAs, and so there's some leaky telomerase expression. But stem cells don't produce telomerase, and this is a really big problem in the stem cell field. And this is why I'm often a speaker at stem cell conferences, because a lot of times when people try to isolate stem cells from the gut or the blood, bone marrow from a 80-year-old, they don't work. Because as soon as they inject them back in, they start dividing, their telomeres get short and the cells die of old age. So the stem cell field, in fact, even like burn victims, let's say that had to have skin transplants and stuff like that, and so they're getting skin from other parts of their body, they have to culture these cells, just like stem cells, to make a lot of the skin and then put it on. Well, 15 years later, that skin starts wrinkling like old skin, where the rest of them, they're still young, okay, because that skin got older. And it's because stem cells have telomere shortening. So a big goal, like reason why I'm asked to speak at stem cell conferences a lot is because the stem cell community would benefit a lot from a telomerase inducer that would re-lengthen telomeres in stem cells and keep the telomeres from shortening in stem cells. So, good. Malcolm, what did you have?
So I was going to ask about two things. What we notice with the Isagenesis, the product B, is two things: increased energy and reduction in pain. Okay, and I was going to have you address those because I keep thinking about the mitochondria.
Yeah.
And I call it the Starbucks disease. That puts you in Starbucks at 3 in the afternoon. You
Okay.
know,
Oh, I see. Yeah,
you just
being
wiped
tired.
out,
Yeah.
Right?
Well, I'm not certain. I can tell you that lengthening telomeres will increase wound healing. Okay, why it would reduce pain, I don't know. My guess is that there's other ingredients that have nothing to do with telomere lengthening in Isagenesis. Because if you look at the bottle, there's a lot more than 5 ingredients in there. There's others in there. There's actually some antioxidants and anti-inflammatories too that I know do not induce telomeres. So my guess is that if you're seeing a reduction in pain from Isagenesis, it has something to do with one of the other ingredients in there. Because I've never noticed a reduction in pain, but I've never even thought about it. So next time I get an injury, I'll think about it.
Okay. Time to go to the tour.
No,
I
Candace.
wonder, because I've had a dramatic decrease of pain, and well, there was that time when Isagenesis was no longer available.
Yeah.
And I have made some funky thing with my order, and so I didn't get my complete essentials, which I'd been on since the beginning, and I had pretty bad arthritis, and it just went away and is gone. And then I couldn't get my essentials, but I just had the Isagenesis, and the inflammation came back.
From just the Isagenesis.
Yes.
So it's the complete essentials.
So it's the complete essentials.
Yes.
What's in there?
Complete Essentials is
Doing
an
that.
amazing product. And I think that there's a lot of things in there that would reduce pain. And I'm wondering if that may be what you're doing. Is you're
That's
doing
what Alex thinks.
Complete Essentials. Yeah.
Well, the omega-3s that are in there,
And the
CoQ10, those antioxidants.
Yeah.
The catalase goes up in the we have the catalase study on the Isagenesis.
Yes.
That goes up 15 plus.
That's what
percent,
Suk Chol did,
which
yeah.
is what is known as scavenger.
As an antioxidant, yeah.
Yeah, of hydrogen peroxide.
Well, yeah.
Right, which is a lot of the damage.
Yeah. And
So I
it's
think that has to be.
hydrogen peroxide actually specifically damages telomeres too. You missed it. No, that's
I took it next.
that's Jason. Yeah. Okay. Oh, there's Dylan and Hope. Okay. So, are either one of you guys interested in science? Okay. So you might like this tour.
Oh,
Yes.
question. Where'd you get your coffee cup?
I don't know.
That's awesome.
It's Molly gave this to me for last Christmas. Yeah.
Yeah.
But yeah, it's got all kinds of great things. Just doesn't have my picture though. Someday. So do you guys want to do the tour now?
Sure.
Yeah.
I think
You have to be the
those most interested in actually what we're doing in each lab should be close to me. If those who just want to see in the labs, get behind. But you two want to be right with me. Where's okay, so. All right, so yeah, so if you really want to know what's going on in the lab, then be right next to me. But otherwise, drag behind and just take a look in. But these pictures here are when we first discovered telomerase. That one over there is the email that we sent to the world, essentially saying that we had discovered it in 1993, I think it's there, 1994. We got together celebrating our 10-year anniversary of discovering telomerase. And I've never heard of anybody doing that before in this field of science. We were all at different companies at the time. We all got together back at Geron Corporation and celebrated a 10-year anniversary and actually presented an award to the scientist that actually ran the definitive electrophoresis gel that I then took and was able to identify telomeres from. So Let's go this way. So, where's Dylan? Okay. So this guys, girls, is one of the most powerful microscopes you can get to look at things by light. Okay, you can get more powerful with electron microscopes, but this is, we actually can look inside of human cells. These are pictures of the insides of human cells, and this is important for us because it tells us about how particular cells are surviving the treatments that we're giving them. And they're different colors because we use fluorescent stains to detect different things. What was the question?
What kind of type of microscope?
This one is, I don't even remember. We have Zeisses and Nikons here. I can't remember which one's which. Does it say? Wait, it says on the, this is a Zeiss. And we have others I'll show you later. This lab here, this is where we do most of our culturing of human cells. And we store them in this liquid nitrogen tank, which is like about the temperature of outer space, really, really cold inside of here. I can't open it up to show you, but that's where we keep our different types of cell lines. Then we actually culture our cells in this room here. And the reason why nobody's in here working right now is because everybody goes home when I give these tours. But scientists will sit here at these stools and then stick their arms in here and work with human cells. And this will be a sterile environment because these vents here are pushing the air out. So any bacteria floating in the air will not go into here. And then when they get done, they grow them, they put the cultures in these incubators. Here they're called CO2 incubators where human cells and things like that can grow. But we have more microscopes, a lot of like pipette men, a lot of different gadgets, just like any lab does. And let's go back out this way. This is what I meant. It's like hard to get everybody in there at once. Let's see. So we have a lot of freezers and refrigerators, same kinds you buy for your home and stuff, but some of these things are, actually, let me show you this one. This one's minus 80 degrees centigrade. I don't know what that is in Fahrenheit. Could you stick your tongue on that? I'm just kidding. It'd be worse than sticking your tongue on any light post. But that, we can't keep this open because it warms up. We store a lot of our cells, the cells we're working with, in there. Remember in the talk I showed you, we're made of 100 trillion cells. Well, we culture these cells here. This is our kitchen. This is like any company that's focused on health is going to have a room like this. This is our athletic room. We do a lot of yoga in here. We have weights and stuff. So a lot of the scientists here come in here and do. Boy, there's a lot of people here. I didn't see this many people in the room. All right, let's go in here because this lab probably be one of your more interesting ones. Sorry about the sound of our computers. This is where John Anderson's samples come. This is the first place. So, like every time John Anderson sends us stuff, they come in tubes and boxes, tubes like these, okay, which would be an extract from some particular plant. And we never know what it is, by the way. I don't know if he's ever mentioned that to you. They're all coded, so we don't know what they are. And it's important, it's always important in research that the people actually doing the actual test be blind to actually what they're testing, because otherwise you can fake data. And you know, we don't fake data, but we want to make certain everybody knows that. And so we're blind to all these things. But the samples get brought into here, they get weighed out, put into things called microtiter dishes. And let me see if I can find one here. And there's none in here right now, but in other labs I'll show you what are microtiter dishes, where these powders get dissolved into dishes that the robots that I'll show you later can handle. So let's go. This lab was and still is somewhat a molecular biology lab before, the next one I'm going to show you is still a molecular biology lab, but that's where we engineer genes to, make them better, et cetera. But this is our molecular biology lab. And so we do a lot of what's called electrophoresis here, using things that these are called gel boxes, and we run something like Jello. We put Jello, think of Jello like a sponge, and if you put an electric current through that sponge, things with a charge will move through it. Well, because of all the pores and stuff like that, smaller things will move faster than larger things. So after a while, you stop the current and you look at where everything is, and it tells you, here's the small stuff, here's the larger stuff, here's the largest stuff. Well, we do this with like gels that are like Jello, and the pores are so small you can't see them. But we send DNA through them with an electrical current, and that way we can separate one DNA molecule from another. And so this is, and then we engineer them, we mutate them, we change them in every way, we put them back into cells, and that's what this lab mostly is for. So this is actually not the most exciting room. This is where glassware washing is done, but I want to show you something outside here. It's kind of interesting. This is a Rolls-Royce jet engine that's inside this box here. And it's all fed by propane in all these pipes. And when we have a power failure in Reno, we never see a light flicker in here. And people are stopping by all the time when there's a power failure in Reno, and they wonder why all our lights are on. How are we doing it? It's because of this machine here. This will kick on within like 2 minutes after a power failure. And while we're waiting for it to kick on, we have batteries that completely keep things going in the process. All right. So the rest of it is autoclaves, dishwashers, things like that. But this is a cold room. It's essentially a walk-in refrigerator. Even in summer times, we'll come in our ski clothes because it's cold in there when we have to work. But it's we have to do a lot of our experiments in the cold, and that's where we do them. This is our PCR room and protein chemistry lab. PCR stands for Polymerase Chain Reaction. Have you seen this show CSI? Do you know what that is? It's so when there's somebody's murdered on TV, the police go and they pick up blood spots and identify who the shooter was or whatever. Well, they put the blood into a machine like these two. This machine here is called real-time PCR, and it identifies who the person is. We don't use it for that reason. We use it to identify cells that are producing telomerase. When our robots, that I'm going to show you soon, do assays. Oh, here's an example of a microtiter dish. That's 384 test tubes, essentially. So we'll have a different, like John Anderson's samples, a different one in each well. Then we'll have another microtiter dishes just like this that will have human cells in it. And our robots will take everything out of here and put it into the other ones, mix them, and then incubate them and test them. And the results actually come in this machine. These machines here. We actually have protein chemistry in here too, which it's another electrophoresis kind of thing like I described before, but instead of DNA, we're looking at protein.
And do you use like a generators, some frequencies?
Yeah, that's what all these are, power supplies. Okay, so the voltage and the current and the everything is, we adjust the watts. All right, now, if you look down the hallway there, you're going to see a sign that says no PCR beyond this point. And this is because PCR is such a sensitive procedure that I showed you the PCR machines in there, that O.J. Simpson, now you guys wouldn't remember O.J. Simpson, but O.J. Simpson is somebody that got away with murder because they did PCR of the blood at the crime scene, to identify. When they looked at the PCR, the blood, they did find that it was O.J. Simpson's blood, but there was other people's DNA in there too, and so they ruled that it was invalid because it said that the test wasn't valid because it was showing more than one person had killed O.J. Simpson's wife. But what in fact happened is that PCR is so sensitive that it can actually fly through the air, and their lawyers were actually saying it doesn't fly through the air, but it does. So in order for our PCR reactions to be true, we do not let PCR go beyond this wall here, okay, down this hallway, because a lot of experiments get done there that could have contamination. They have to come into this lab here. This is our transition lab where when we're doing PCR experiments, we'll actually work on these hoods just to do the final touch-ups, and then actually send them through this little box here, put them in there, close the door, and then scientists on the other side will take them out the other side and go to the robotics. So we're going to now walk through this one corridor that connects one half of the building to the other half of the building. What's that? Polymerase chain reaction. It was actually invented by a guy named Kerry Mullis, who used to be a friend of mine. He actually applied for a job with me after he got a Nobel Prize, and I turned him down because I hired a technician instead that worked in his lab that was actually responsible for most of the work. And Kerry Mullis just passed away recently too. But he was the inventor of PCR at Cetus Corporation. Yeah, sorry. All right, so now we're going to go from one side of our building to the other. Oops. So scientists on this side will take the samples out of here, take them into this lab that you just passed by, which is just another processing lab, before we actually take them into the robotics. You'll see a lot of duplicates, more incubators here, another liquid nitrogen tank, only because we don't want to be taking things back and forth to the different sides of the building. But here is our robotics room. And I said before, there's no humanoid looking robots, so don't expect to see anything. And we actually don't ever let these things actually do experiments when there's people in here, well, unless there's special people. So we actually have a glass window there that people can watch through that window over there. But this is one robot. It does the initial processing. And then we put them into this robot. It has an incubator. This does have an arm that has fingers on it. The fingers aren't on it right now. The fingers go on this arm like this, and they can actually grab these microtiter dishes. This one has 96 different test tubes. The other one I showed you had 384 test tubes. These robot arm will carry this thing, take it all around here and do different steps of the experiment. And the results end up showing up on those PCR machines that I showed you in the other room. But it's like, here's another microtiter dish. The robot will carry this over. That robot arm will slide along this arm, put this thing in here, turn this on, shake it, mix it up. They'll put it in here. This arm will move around and do things. It has things that come down and pick things up and add liquids. It's called a liquid handling station. Now we'll go out this way here. Oh, and I should have mentioned, everybody really should step on that blue mat because it takes dust off your shoes. This room here is very sensitive to the air, so it's got some strong filters. But we don't have to really when there's no experiment. But that's what the blue mats are for, is to take the dust off your feet. So as soon as everybody comes out, we'll go into this room here. This is our warehouse, shipping, receiving, and stuff. It's actually, we do plan on building this room out a little bit, but so that line right there is black and yellow. Again, we keep people from going across that because of PCR contamination again. But nobody's working there, so it wouldn't matter right now. But this whole corridor here is for PCR, and we don't allow people to go across that line when there's anything being done. On this other side of the room here, well, you can see all my suits and stuff like that. So when we have a visitor or something like that, I can change clothes. But this here is all of our gene therapy area. So most of our work with gene therapy, which is kind of like a virus. Okay, it's not a real virus, it's an artificial virus, but it works the same way as a virus to deliver DNA to your cells. And so you'll see signs over here, virus only, etc. But this is where we do most of our gene therapy. And pretty much the rest of that back there is just storage and stuff. And so you've seen the whole company now. Okay, so it's about 10,000 square feet of lab space. We are thinking of expanding, getting even bigger. In fact, we can actually go through that wall and that wall to actually increase the size of this building. All right. Did I pass anything? Anybody want to go back to? Any questions? Yeah. All right.
I think somebody mentioned to me they weren't here in time to get the books.
Oh, yeah.
Who was that who needed the books?
Well, they just happen to be right here. Who needed the books?
I'd like
Jack does.
Jack does.
Green one for me.
And I would like
Where's yours?
Well, which one? Both of them?
No, not the curing agent. I have that one. It's the green
One mind, one love, one heart, one soul. One life, one chance, one head.
Let's dance inside, let's dance for a while. Heaven can wait, we're only watching the skies. Hoping for the best, but expecting the worst. Are you gonna drop the bomb or not? Let us die young or let us live forever. We don't have the power, but we never say never. Sitting in a sandpit, life is a short trip. The music's for the sad men. Can you imagine when the race is run? Turn our golden faces into the sun. Praising our leaders, we're getting in tune. The music's played by the madman. To be forever young. Do you really want to live forever?
One life,
forever,
one love,
and ever.
one soul.